There's a 4.35-ton stone statue standing on Easter Island right now that, according to a 2025 study using physics, 3D modeling, and a full-scale replica, was never dragged, never rolled on logs, and never hauled flat on a sled. It walked there, upright. A small team of people gently rocked it from side to side using ropes, moving it forward one careful pivot at a time across the landscape, like guiding a giant toddler learning to walk. This incredible discovery opens up a much bigger question. How did ancient humans, separated by oceans and thousands of years, build some of the world's heaviest and most precise structures using nothing more than rope, wood, stone, water, and coordinated human effort? No cranes, no trucks, no electricity, just people who understood physics through observation and experience, even without formal mathematics. They solved enormous problems by organizing entire societies around common goals and by working with nature rather than against it. The Great Pyramid of Giza remains one of the greatest examples of this achievement. It contains more than 2.3 million stone blocks, weighing between 3 and 90 tons each. It was built without iron tools, modern machinery, or wheels for heavy transportation, yet it still stands more than 4,500 years later. Contrary to popular belief, archaeological evidence suggests that the pyramid was not built by millions of slaves. Instead, around 4,000 skilled workers, supported by 16,000 to 20,000 additional laborers, managed the entire project through remarkable organization and logistics. For many years, historians believed the stones were moved using one enormous straight ramp leading to the top of the pyramid. Today, many researchers reject this theory because building such a ramp would have required more material than the pyramid itself. French architect Jean-Pierre Houdin proposed an alternative idea. According to his theory, an external ramp was used for the first 30% of the construction, while the remaining stones were transported through a spiral ramp built inside the pyramid. Once the external ramp was no longer needed, its materials could have been incorporated into the upper layers of the structure itself, explaining why no giant ramp remains today. Another fascinating detail comes from ancient Egyptian paintings showing workers pouring water in front of sledges carrying heavy stones. For centuries, scholars assumed this practice was ceremonial, but modern physics proved otherwise. Adding the right amount of water creates a thin layer of cohesion between sand particles, dramatically reducing friction and making heavy loads much easier to pull. The Egyptians had discovered an important principle of physics through practical experience nearly 4,000 years before scientists formally explained it. Thousands of miles away, another ancient civilization faced similar challenges while constructing Stonehenge around 2,500 BC. Some of its stones weigh as much as 30 tons, but the real mystery lies in transportation. Certain stones came from Wales, nearly 200 miles away from their final destination. Without wheeled vehicles or powerful draft animals, moving such enormous weights across difficult terrain seems almost impossible. Researchers believe the builders relied on a combination of wooden sledges, log rollers, river transport, and coastal rafts. Water carried much of the burden whenever possible, reducing friction and human effort. Once the stones reached the construction site, builders likely used levers, counterweights, and controlled rocking motions to raise them. Instead of attempting to lift 30 tons at once, they gradually pivoted each stone upward inch by inch. Rather than fighting gravity directly, they worked alongside it, turning an impossible task into a series of manageable steps. Perhaps the most fascinating example comes from Easter Island and its famous Moai statues. Some weigh more than 80 tons, and for decades, researchers believed they had been dragged horizontally on sledges or rolled on logs. Yet the evidence never fully supported these ideas. Archaeologists found no roller marks, no sledge tracks, and no signs of heavy dragging along the ancient roads. Meanwhile, local oral traditions consistently claimed that the statues simply walked. For many years, scientists dismissed these stories as folklore. However, in 2025, anthropologists Carl Lippo and Terry Hunt decided to test the traditional explanation scientifically. Their research revealed that transportable moai shared two important design features: a wide D-shaped base and a forward lean of 5 to 15 degrees. These were not merely artistic choices, but deliberate engineering solutions. The method itself was surprisingly elegant. Workers attached ropes to both sides of an upright statue, and teams alternated pulling from left to right. This caused the statue to rock back and forth. Because of its forward lean, each rocking motion generated a small forward movement. Repeated continuously, the statue effectively walked across the landscape. The principle is similar to moving a heavy refrigerator by rocking it from side to side instead of dragging it flat across the floor. Researchers tested this theory by building a full-scale 4.35-ton replica. 18 people successfully moved it 100 meters in about 40 minutes. Their experiment suggested that an average moai could travel roughly 1,000 feet per hour once the movement was established. The hardest part was simply creating the initial motion. After that, momentum and pendulum dynamics made each subsequent step easier. The ancient roads themselves appear to support this theory. They were consistently about 4.5 meters wide and gently concave in shape, providing stability for upright statues while actually making horizontal dragging more difficult. Even the statues abandoned along these routes fit the explanation. Many were found close to the original quarry, suggesting that failures occurred during the most challenging early stages of transportation rather than as part of deliberate placement. What unites the pyramids, Stonehenge, and the moai is not shared culture or direct contact, but a common approach to solving enormous physical challenges. These societies independently discovered the same fundamental principles. They reduced friction wherever possible, whether through wet sand, wooden rollers, or specially designed roads. They transformed impossible tasks into smaller, manageable steps through ramps, rocking motions, and gradual movement. They used natural forces such as water, gravity, and momentum to carry much of the burden. Most importantly, they organized human labor with extraordinary levels of coordination, planning, and shared purpose. None of these achievements required modern technology in the way we understand it today. They required something perhaps even more impressive: entire communities willing to work together for generations, combining practical knowledge with patience and persistence. Ancient people understood physics not through equations and textbooks, but through observation, experimentation, and the accumulated wisdom of countless individuals before them. The next time you see the pyramids rising from the desert, Stonehenge standing against the English sky, or a moai watching over the Pacific Ocean, remember that none of it was magic. These monuments were built using nothing more than rope, water, wood, stone, and coordinated human effort. Ancient civilizations created their own machines out of the resources around them and their deep understanding of how the natural world works. They simply kept trying, generation after generation, until the laws of physics cooperated with their determination, one careful step at a time.